All right, 7.6, last section in chapter 7. So now we're going to put that 4-step process into play, and we're going to build our confidence intervals for a mean and interpret them. Okay. Now, there's one thing we have to talk about first, and it has to do with the conditions. So to satisfy the normal large sample condition, we were told that the data has to come from a normally distributed population, right? So for the normal large sample condition, either the population is normally distributed or the sample size is large, greater than or equal to 30 by the CLT, right? But what if the sample size is small and the shape is unknown? What if both these don't work? Is there a third route we can go? And yes, your third option here is to graph the sample data. I like to use dot plots. You'll see them use various different dot plots. And what we're trying to do is we're trying to show that the sample distribution is either roughly symmetric or only moderately skewed and has no outliers. If that is the case, then we're going to use the sample data graph to then go back and say that we think the population is approximately normal. Okay, so this is going to be your third option in the normal large sample condition. So again, in summary, how do we check for the normal large sample condition? Number one, look for the word normal in the problem. Is your population normal? Number two, look at your sample size. Is it greater than or equal to 30, which applies to the central limit theorem? Or last but not least, you need to graph the data, graph the sample data, and show that there's no strong skewness outliers. And again, you're just going to write this verbatim. Graph of the sample data shows no strong skewness or outliers. If that is the case, you move on and you assume the population is approximately normal. Okay, so I have two examples here. Example one, or part A, are the conditions met? Determine if the normal large sample condition is met for each of the following settings. How much force does it take to pull wood apart? The stem plot shows the force in pounds required to pull apart a random sample of 20 pieces of Douglas fir. So I'm going to go through the whole checklist. Number one, does it say population in the problem, or say normal population? No. Number two, what's your sample size? Your sample size is 20. That's not big enough. So the number three, they have the stem plot for you already. But now look here. Again, stem plots, you have to kind of turn your head, right? But if you look, to me, this guy looks pretty strongly skewed to the left. So in my opinion, this would not meet the normal large sample condition. So when it doesn't meet, I need you to explain all three parts. So we're going to say normal large sample condition is not met. Is not met. Number one, the population shape is unknown. So the population shape is unknown. Didn't tell if it was normal. Number two, your sample size is 20, which is less than 30, fails the CLT. And number three, your stem plot of the sample data shows, we're going to call this strong skewness. Shows strong skewness. And that's a deal breaker, right? So there we go. Okay, so there's a situation where you could not then assume the population is normal, and you could not build the confidence interval like I'm teaching you. Okay, let's go to part B. So we'll change colors here. So part B says, suppose you want to estimate the mean SAT math score at a large high school. The box plot summarizes the distribution of SAT math scores for a random sample of 12 students at the school. Number one, does it say population is normal? No. Number two, what's your sample size? Sample size is 12. That's less than 30. Not good. And then number three, we look at the graph. Now, I understand that this tail is longer than that tail. But to me, this is not strong enough skewness to rule this data out. So we are going to say that this does pass the normal large sample condition because this box plot of the sample data shows no strong skewness or outliers. So we're going to say the box plot of sample data shows no strong skewness or outliers. So then I'll put met. Okay. Now, the one nice thing, this book sometimes gives you the data and then wants you to draw the dot plot. I will be nice enough. I will have the dot plots provided for you. Um, you just have to make sure you put this wording right. And again, notice the wording. The whatever your, so most of the time it's a dot plot, but this was a box plot. Box plot of sample data shows no strong skewness or outliers, verbatim from your notes. Okay, and that means it's met. All right, cool beans. All right, so the next video is actually going to go through one of the big long 4-step problems.